Matt Lepwich. I'm the President and Engineering Director for Nanomatronix. Thank you for your time today and allowing me to present our AEDC Phase 1 SBIR match application. This is for an Air Force Phase 1 SBIR. The contract went into place last month, well actually in February, and we'll finish up in a couple of months before moving on to the Phase 2. In this presentation, I'll provide a quick corporate overview, a quick overview of our microelectronics SBU. We'll talk about the Phase 1 project, the key innovations, the objectives, the anticipated Phase 2 and Phase 3 objectives, and the need for the AEDC matching.
Nanomatronix was founded in 2005, primarily as a private consulting company, but also beginning to structure a company to push some of my master's and PhD work forward. My master's work being in advanced packaging, microelectronics packaging, and my PhD work being in carbon nanotube synthesis and microelectronics integration. So then backing up a little bit, from 1999 to 2012, I was really overburdened with that consulting work, and I was the COO for Space Photonics Incorporated, helped them generate quite a bit of revenue and had quite a few successes in fiber optic networking and free space optical networking product development. Then in 2011 to 2013, I basically left Space Photonics and was contracted to conduct a large BGA solder ball reliability study for multiple patent infringement cases. And that was an interesting project that kind of kicked off Nanomatronix service-based offerings in regards to microelectronics screening and qualification studies for reliability and lifetime analysis. From 2012 to 2015, Nanomatronix won a NASA Phase 1 SBIR for the continuation of the PhD work, growing ultra-long carbon nanotubes. Did not win the Phase 2, won an Arkansas TDP grant to build that custom reactor. It's in operation today. We've achieved long micron lengths, and our next milestone are millimeter lengths. That will then go back to the DOE for continuation of funding beyond the millimeter length range. We are currently ramping up to the millimeter length range using internal R&D money. 2015 to 2017, we developed a current, more aggressive business strategy that is beginning to play out via 3 strategic business units: the microelectronics SBU, which this particular program falls under, the nanotechnology and biotechnology as well. 2017 to 2018, we had full implementation of the above strategy, leading to the creation of what is really becoming a technology transfer and commercialization consortium, where we've increased our research institute collaboration, increased momentum in all 3 SBUs, several new awards, new patenting and licensing activity, and several new RFQ opportunities. Here we come today, where we now have exclusive licensing rights to 3 UA patents, are pursuing exclusive licensing rights to 2 additional UALR patents, are filing 2 to 4 provisional patents this year for technology that we've developed internally, have had continually increasing yearly revenue at $1.5 million roughly from 2005 to 2017. Then in 2018 we hit 69K roughly. 2019 our projections are about 1.5 million, and then for 2020 the projections are about 4 million, and that's for things that we know or things that we have signed contracts for, and does not include anything else that we have pending. And finally, we are now a 13-employee company with 3 to 6 new hires planned over the next 6 to 12 months.
This project falls underneath the umbrella of our microelectronics SBU. It is for the development of harsh environment fiber optic communication modules for space environments, but also could apply to aerospace and other harsh environments, and there are a couple of dual use applications. But this slide basically just gives you an overview of some of our core technologies and capabilities within this SBU. In this project, we're developing a ruggedized optical interface, an optical fiber optic connector and cable assembly to allow typical commercial off-the-shelf transceivers to operate in harsher environments. The existing commercial off-the-shelf optical interface is that which you see on the right in the middle image. It's a soft contact interface, and therefore under vibration is allowed to move. Therefore, as motion increases or vibration increases over time, you have mechanical failures. In situ with normal operation with too much vibration, you have optical signal propagation failures, and that generates bit errors in your data, and therefore you start having disruption in packet transmission in internet operation, for example. So we can solve this problem by redesigning that optical interface, cable and connector, and that's exactly what we choose to do or have chosen to do in this phase 1 project.
This slide continues to describe what we are doing with the redesign. The white bullets are existing requirements that we must be compatible with, so that the RQSFP Plus modules are compatible with the QSFP Plus COTS devices, etc. The green bullets are the items that we are adding to the design, adding to the production to make sure that they come up to the level of standard that is required for those environments over a longer lifetime.
This slide illustrates the key innovations beyond our commercial off-the-shelf competitors. It also shows how that change results in those changes result in high vibration tolerance. And then based on the vibration tolerance and then the inherent thermal and radiation tolerance of the devices allows them to be useful in harsh environment and some dual use applications.
The commercial opportunity for this project and for the end products that will result is actually very strong. One of the strongest that I've been a part of in some time, and we're very excited about the potential. when we look at the worldwide optical communication market, by basically millions in cells, we've got projections from, well, history from 2014 up through 2018, and then projection out to 2022. But if we look at just the green portion of that chart or that plot, the QSFP portion, that is the projection, well, history and projections of the millions of dollars in cells for that type of package. So that is the one particular type of package that this project encompasses. Now, we are planning on designing the same versions of this ruggedized interface, fiber optic interface adapter for the SFP, the SFP Plus, the CX4s, etc., on up the line, because they are also used and could be used in harsher environments if they had that adapter interface option. And you'll see what I mean by adapter here in a minute. That goes into more detail about some of the components we're changing inside of the enclosure. But I'll get into that here in a little bit. We're keeping this high level with these first few slides. So based on a conservative market estimate, our sales revenue could be as high as $5 million. A yearly sales revenue could be as high as $5 million, and licensing revenue could be as high as $1 million. That's quite speculative during the first year of commercialization. And that's just assuming, I think, a modest, maybe 1% or 5% acquisition of the market share, assuming there are enough customers out there that want the harsher environment version, so they'll pay twice the cost for the part to last 5 years longer or up to 10 years long, et cetera, et cetera. But for example, something to back up that claim or that assumption on how much of the market share we could capture, the Navy sponsor for this project has already estimated to us, or given us an estimate, of the first procurement of these RQSFP Plus modules into our adapters would be about 10,000 units at the conclusion of the phase 2, and that would likely be spread out over a 2 to 4 year procurement period. Well, each of the RQSFP Plus modules in a full version, assuming they're purchasing the full redesigned, reproduced, screened and qualified module, would be anywhere from $1,200 to $1,500 per unit versus around $400 to $500 per unit for the existing commercial off-the-shelf version. So they're paying almost 3x the cost for a screened and qualified version that's going to last 10 years versus a COTS version that might last 2 to 3 years. So that single Navy customer would allow us to reach this conservative market projection within the first year for the NAVC platforms alone. And their interest in the NAVAIR platforms and the SPA-WAR platforms as well, that would be the aircraft and spacecraft that they envision over the next 10 to 20 years.
This slide illustrates the commercial opportunity for the QSFP modules. And shows that there's a sizable market up through 2022, well, exceeding $1 billion per year. And this is, again, isolated to just the green region of that chart, which again reflects the QSFP modules only. We have another project where we're working on a redesign of the SFP Plus modules, and then we have a partner interested in having us look at the CXP and CFP modules as well.
This slide describes the phase 2 and 3 objectives that we're about to start working on. I won't read them verbatim. Instead, if you would like, just simply hold on this slide and take time to read through these objectives. But they simply express more detail about what I had just said in the previous slide. That we're now testing the parts, or prototyping and testing the prototypes, going into pre-production, and then going into production.
There are 3 basic needs for this AEDC match that will allow us to more or less enhance our phase 1 results going into the phase 2. The first need is to procure additional piece parts to build 10 additional SRQSFP prototypes, and this will cost about $10K. The $50K match will provide 100% of this need. The second need is to conduct additional vibration, temperature cycling, mechanical shock on screen, and mechanical shock screening on 5 prototypes, and this will be approximately $15K. And the AEDC 50K match will provide 100% of that need. And then the third need is to use the remaining balance for employee retention. So it will partially support the retention of 1 full-time employee through phase 1 to phase 2 transition. It will support the retention of 1 part-time employee through phase 1 to phase 2 transition. and then that one part-time employee will transition to full-time upon phase 2. Without this match, we will not be able to produce additional prototypes to get ahead on the screening tests that will aid in DoD prime consideration for larger system-level integration and demonstration activity, and it will allow us to retain 2 jobs during the phase 1 to phase 2 interim.
Thank you for your time. Thank you for viewing the presentation, and we look forward to continuing to work with the Arkansas Economic Development Commission.